I did suggest that you guys find these notes in Schoology because there will be a lot of wanting to go back a step here, and you'll be able to do that if you have the slides open yourself. So today we're going to learn about the chi-square test. And we are going to do a problem first that seems a little bit similar to one we've done before with a significance test. We have a bag of M&Ms. There are 61 M&Ms in the bag, and 9 of them are blue, but the company claims that 24% should be blue. So do that quick calculation, and you should discover that 9 over 61 is really not that close to 24%. I think I did it last night. Let's see what I got. Nope, it's not on this paper. Oh, I got 14.8%. Anybody else getting 14.8%? Okay. So 9 over 61 should give you 14.8% blue, but the company says 24% should be blue. Is the company lying, or is this just statistically not significant? All right, so in the past, we did do significance tests, and you could have a null hypothesis that 24% of M&Ms are blue. In general, maybe not your bag. And the alternative is that 24% of M&Ms are not blue. And if you do that, just going through the steps of significance testing, you would get a z-score that was negative 1.69. And remember that we take the absolute value of that, which made it positive. You got a p-value of 0.0455, multiplied it by 2, and you got a value that was higher than your significance level of 0.05. So that's a very quick review of significance testing. And remember, we have the slides on day 2 of significance testing if you want to review that process. All right, so that would work here. So it says, since it is greater than 0.05, the null hypothesis is likely true. We don't have any evidence that their claim is false. We just have an outlier bag. But there's another test that we could use to get a more accurate result, and that's this chi-square test. Okay, so this chi-square test is used to see if two variables are correlated or if they're independent. And so in this example here, we could see if students of different grade levels had different views on whether or not Seahawk Seminar should be changed. So you can see the data here. We've got freshmen, sophomores, juniors, and seniors, and their opinion about changing it or keeping it the same. So what we're wondering is, does it matter what grade level they're in to determine whether they think we should change it or keep it the same? Just going through the numbers real quick. Freshmen, 7 said change it, 14 said keep it the same. Sophomores, 9 said change it, 12 said keep it the same. Juniors, 13 said change it, 9 said keep it the same. And seniors, 14 said change it, and 7 said keep it the same. All right, so to do the chi-square test, just like with significance testing, you need a null hypothesis and an alternative hypothesis. In this case, the null hypothesis is that grade level and view on changing Seahawk Seminar are independent, and that means that your view on Seahawk Seminar has nothing to do with your grade level. And the alternative hypothesis is that grade level and view on changing Seahawk Seminar are not independent. So your grade level will tell you something about your view. All right, we have this new value. It has kind of a fun name. It's called degrees of freedom. Degrees of freedom is the rows minus 1 times the columns minus 1 of our table. So if we look back at our table has 2 rows and 4 columns. And so you subtract 1 from the 2, you subtract 1 from the 4, you get 1 times 3. So your degrees of freedom is 3. Now that number, we're going to set it aside. We're going to be using that at the end, but just remember we calculated the degrees of freedom. It wasn't that hard, right? So like I said, guys, chi-square testing is not hard. It's just complicated. There's like a lot of steps to it. Personally, I would have waited to calculate that degree of freedom later just because we don't need it yet, but it doesn't matter. All right, find the expected values. So we're going to think first about an easier expected value. For the M&Ms, if the company says that 24% are blue and you have 61 in your bag, we can calculate an expected value for that, right? So we can calculate 24% of the M&Ms will be blue. And if I multiply 0.24 times 61, I get 14.64 blue M&Ms. Expected values can be decimals, even though we know we're not going to really get a 0.64 M&M. I mean, sometimes you do, but anyway. And so expected values can be decimals. And what happens here? So we're going to use a formula on Seahawk Seminar. And this is another example of complicated but not hard. So for this Seahawk Seminar, we're going to go back to your keep it and change it. And actually, I'm going to pause for a minute because what I want to do is I want to put some numbers on here. We need some totals. So to find our new table, so here's our old table on the top, and to find our new table on the bottom for expected values, we need to know the row total and we need to know the column total. And I wonder if I just resize this, if I can make room for those. I'm just trying to make, oh, it doesn't want to go any smaller. Unfortunately. I can make this smaller though and make room for it. Okay. All right, so what we're going to do is we're going to find the totals. We're going to find row totals and we're going to find column totals. So we're just going to add them up. And I'm just going to use text boxes instead of making a new column here. Okay, so our row total here, I think I cannot write in black. I'm going to have to change my color and change it to white. Okay, total equals 43. And then I'm going to make a total for the next one. This row total is 42. And then I need my column totals here. Okay, so column totals, 21. Oops. I have to keep remembering that I can't write black on black. 21. Another 21. And then a 22. And then a 21. And then what we need is we need the total of the totals. So you know that going across and going up and down, they should total the same number. And so that's a good check for you. Make sure that they add up to the same number. And you should get 85. Let me see if I can choose a new color here. Maybe we'll do purple. Purple is not a good choice. Try green. Okay. All right, so you guys see how I totaled that, right? Adding is not hard. All right, so next, we're going to use this formula. So to find the first cell, you're going to take the row total times the column total and divide it by the sample total. So I'm going to ask you to find any calculator. It could be your phone calculator, it could be Desmos, and let's just try that. To find this number right here, to find 10.6, I'm going to take my row total, 43, and I'm going to multiply it times my column total, 21, and divide it by 85. Please do that now. Practicing that step is going to help you. I'll tell you one more time. Row total, 43. Column total, 21. Divided by 85, and you should get 10.6. All right, raise your hand if you got 10.6. 1, 2, 3, 4, 5. Good. Raise your hand if you got something different. Okay. All right, and so that's how it works. Like if I want to get this number down here, this 10.9, my row total is 22. I'm sorry, my column total is 22. My row total is 42. I multiply those numbers and then I divide by 85. So this gives us the expected values. And it's a little bit more tricky than the expected values for the M&Ms. We're going to be doing that in your classwork today too. Okay. Then we get to this. So these numbers, the first two columns, these are the numbers we already have. You have your expected values here, and you have your observed values here. So going back, we expected 10.6 of a certain color M&M, and we had 7. All right, and these are all observed values and expected values. You subtract them. So 7 minus 10.6 is negative 3.6. Subtracting is not hard. You square that number. So negative 3.6 squared is 12.96. And then you divide it by its expected value over here. Okay, so all of those things are easy to do. They just take a little bit of time. For our classwork today, I'm going to suggest that you work with a partner because there's a lot of calculation and it could take some time. So if you split up the work, you'll do a little bit better. If you're good with spreadsheets, you might be able to manipulate a spreadsheet to help you do it faster. All right, so we're going to look up the critical value now. So this is a table that we use. You can see the degrees of freedom are on the left, and you'll remember that we had a degree of freedom. I actually forgot. We did find our degree of freedom though. It was here. We found it was 3. Okay, so we're going to be looking at degree of freedom 3. Usually we do a 5% significance level, but there is a problem in your homework that asks for a 1% significance level. So just pay attention to your significance level. And you find your critical value here, the 9.4, nope, I'm too low, 7.815. Okay, so it was degree of freedom 3 and the 5% significance level. And here it is down here, it says 7.815. All right, and then we draw a conclusion. So if your calculation is greater than your critical value, then you'll reject the null hypothesis and accept the alternative hypothesis. If your calculation is less than the critical value, you accept the null hypothesis. One thing I forgot to show you is how we got the final calculated value. So I'm going to go back real quick to show you that. It's here. So this notation here means sum. So basically you take your last column and you add it up. And that's going to give you your critical value of 5.814. We're comparing that now to, that was your calculated value, and we're going to compare it to the one from the table, 7.815. Since it's less, we're going to accept the null hypothesis, which means that your grade level and your opinion on Seahawk Seminar are independent. One does not have anything to do with the other. All right, so this is it for the notes. Like I promised, there are a lot of steps to it, and you're going to want to keep these notes open so that you can go back as you work through your classwork activity today.